Hi, everyone. Welcome back to Child Development. Today, we're going to talk about research methods and research design. Now, the reason why you want to really pay attention to this video is because in order for you to be critical consumers of developmental science, you need to understand how studies are done, what criteria make a study good. And when you encounter random claims in the media, like vaccines might cause autism or playing classical music to your baby might make them smarter, you can kind of have good tools in order to assess how good the study was that maybe made this claim, whether the media is making claims that the study never actually meant to make. And if you're interested in doing child development research yourself, this is going to equip you with some tools and some insight into how the process is done. But before we dive into the process of research design and method, it's important that we cover a couple of things first in terms of how research and design in child development is done within the scientific method. Because remember, everything in psychology, including child development research, follows the scientific method because psychology is a science. The scientific method is guided by an observation or a question that you have. Then you create hypotheses about how or why this particular observation or question happens, how it occurs. Then you collect data in order to assess your hypothesis. And then after you collect your data and you do statistical analyses on them, you can kind of draw a conclusion as to whether the data you collected supports your hypothesis. Now, it's really important to understand that there is a big distinction between theories and hypotheses and what it means to provide evidence for a particular theory or hypothesis, which we're going to dive into. But for now, just make sure that you understand that all research in child development follows the scientific method, and we all develop a hypothesis. We choose the best design and method in order to test and collect data to probe our hypothesis, and then we make conclusions or revise our hypothesis based on the data that we collect. Now, although all scientists in psychological science and child development follow the scientific method, there are two types of scientists: those that want to do basic research and those that want to do applied research. So basic research are people that do research for the sake of knowledge. So an example of a basic researcher would be someone that wants to uncover the different factors that contribute to a child's self-esteem. So they're basically doing basic research because they're just trying to find the different components that make up a child's self-esteem. Whereas in applied science is implied in the name, right? You want to apply the research in order to better children's development. So again, taking the example of self-esteem, an applied scientist would research whether different interventions aimed at improving self-esteem are effective. So these are the two different types of research that people within child development might pursue. Now, in order to dive into the design and the methods, it's important to first review what a law versus a theory or a hypothesis is. So a law we never deal with in psychological science or child development. And the reason why we never deal with a law is because a law is always true no matter what across contexts. And given that we study really complex systems like children's development, we can never know for sure whether our findings are true in all cases across all individuals, across all contexts. A law is something like 1 + 1 = 2, because no matter what, that will always be true. So in psychology, we can never really be certain that what we find, our results, are true across all contexts. But that doesn't mean that the science isn't just as good. It just means that it gives us opportunities to always fine-tune and revise our theories. So our theories are basically an account of why something happens. But I want to correct a common misperception about a theory. Some people, when they hear, for example, the theory of evolution, they say, well, that's just a theory, as if the theory was simply an idea that someone came up with randomly. And that is not the case, okay? Theories in child development and psychological science are supported by various hypotheses that have been tested with a lot of different studies, meaning that established theories have been tested over and over and over again using different participants, different designs, different methodology, and based on the amount of evidence supporting that theory, that's why that theory exists. Does it have room for revision? Absolutely. We don't always get it right. However, a theory isn't just an idea that someone came up with randomly. It is an account of how or why something happens that has been supported by a lot of evidence. Next is a hypothesis. Now, unlike a theory, a hypothesis is a possible explanation for an observation or a question that you have that can be either refuted or it can be accepted based on the type of data or the results that you get from the data that you collect. But again, like we talked about, you can never prove that a hypothesis is true, okay? You can only say that your study provides evidence for your hypothesis. Again, because in psychology, we're dealing with so many complex systems, the human mind, the brain, the fact that we exist in a social environment, we can never say that we have proved something. So if you ever see any study or anything in the media claiming that science has proved something, specifically in the realm of psychological science, then be very wary, because no reputable scientist that is in the psychological science is ever going to say that they have proved anything, okay? So we have theories, hypotheses, and now we get to dive into the fun part, which is the different types of designs and methods that scientists get to use in order to test their hypothesis or answer their questions. So there is a difference between design and method, okay? When we talk about design, we talk about the type of study that is the most appropriate for you to explore your question. And then when we talk about method, it's basically the tools that you are using in order to explore or measure the variable that you're interested in. So the design is kind of the setup of the study, and the method kind of includes what you did in your study. So first, we're going to look at research design. Research design includes things like observational studies, correlational studies, experimental studies, case studies, cross-sectional studies, and longitudinal studies. So these seem to be the main designs that researchers in child development use in order to explore their questions. An observational study is basically plain and simple, which is why there's nothing on this slide. It is literally just going into the environment of a child, whether it's their home or the playground or school, and observing and documenting their behavior in a naturalistic setting. Nothing's being manipulated, nothing's being asked of the child. An experimenter is simply going to see and observe what the child is doing. So something that might be good for an observational design might just be the type of play that happens in 2-year-olds in a school setting. Do they interact with each other? Do they play next to each other? Do boys and girls play with each other? These are the type of questions that an observational study might seek to answer. A correlational study, on the other hand, goes beyond an observational study because it tries to seek whether two variables are related to each other, and if they are, how. So an example of this might be to see whether IQ is related to income, because you might predict that the smarter you are, maybe the more opportunities you have to have a good job, and therefore that might relate to income. But what is the problem between making really strong claims about IQ and income? The fact is that there's always going to be a third variable problem, meaning that there can always be a third variable that might explain the relation between the two variables. In the example of IQ and income, you might imagine that age, for example, might be such third variable, where it's not necessarily that smarter people are more likely to get higher incomes, but maybe IQ, because it improves, throughout the lifespan, depending on the age range you're testing, might account for this relation, right? So you can't really say that IQ caused income. Additionally, in a correlational design, you can never have a directionality, meaning you can't ever assume that one thing led to the other and vice versa. So a correlational could be that income makes you smarter because maybe more access to resources allows you to develop your intellect, and therefore maybe that improved your IQ. Totally possible. So correlational designs cannot tell you if one costs the other, and it also doesn't tell you directionality, right? So which one cost which. Now, the example I gave about IQ and income is a little innocuous. If we were to misinterpret that, maybe not as many bad things would happen. However, we need to be extremely careful because there has been a lot of really bad movements based on people's misinterpretation of correlational findings. So one really popular misinterpretation of a correlation that you might have seen in the media is that people have misinterpreted the correlation between the amount of vaccines available and the prevalence of autism. Now, it is true that the amount of vaccines have gone up and that the autism prevalence has gone up as well. But again, this is only correlational, okay? Meaning that we can't know if one caused the other. Not to mention that there's a lot of really good explanations as to both of these have increased. In terms of the increase in prevalence in autism, we know that we're a lot better at detecting and diagnosing autism, meaning that maybe it's not that more kids are getting autism, maybe we're just more better able to diagnose autism. So maybe it just seems like the prevalence has increased. Along the same lines, we know more about epidemiology, diseases, and vaccines, meaning that maybe we're vaccinating more because we know that vaccines can really help prevent some really devastating diseases like polio and chickenpox, measles, things that can be fatal to children. You know what else has increased along with vaccines? Fast food, the number of people that go to college, the sale of organic food, but no one would ever make a claim that the amount of people going to college is causing autism prevalences, right? So it's really important for us to be very careful about how we interpret correlations. Now, in order for anyone to ever make a claim that vaccines made autism, they would have to do an experimental design. And we're going to dive into an experimental design here soon. But the point I want to make is that we cannot do an experiment which can give us a causal interpretation between the relation of vaccines and autism because it would be unethical. In order to draw a causal interpretation that vaccines cause autism, you would have to randomly select a sample of children who would either get a vaccine or not get a vaccine, and then measure the prevalence of autism there. And of course, this is unethical. One, because if you actually believe that vaccines give autism, then you're not going to willingly give children vaccines, right? And on the other hand, if you believe, like all the science shows, that when you don't vaccinate kids, you're making them susceptible to potentially getting these diseases that might be fatal, then you also wouldn't want children to be unprotected and not get vaccinated. So that study can never be done. However, there have been studies that provide a lot of evidence to suggest that vaccines do not cause autism. For example, one group of researchers gathered data from children that had gotten vaccinated and not gotten vaccinated within a period of time. And they controlled for a lot of factors, meaning they accounted for things like age or the parent's income, their nutrition, all of the things that you want to account for. And then they compared the prevalence of autism between the group that decided to get vaccinated and the group that had not. Now, remember, these were not randomly assigned. These were the parents' choices that chose to participate, in this study, or data gathered from information that's out there. And what they found is that there were no differences in prevalence between the children that got vaccinated and children that did not. Meaning that if vaccines did cause autism, right, you would have expected then for more kids that got vaccinated to have a higher prevalence of autism diagnoses, and that was not the case. So if someone has been telling you that vaccines cause autism, you can tell them they're wrong. Okay, so I think I made my point, right, about correlation not being causation. There is, however, an experimental design that can establish a causal link between two variables, and that is experimental designs. So an experimental design has several characteristics that make them special. The first is that you have a dependent variable and an independent variable. The independent variable is a variable that you manipulate in order to see if whatever variable you manipulate is going to have a direct cause on something. So let's take an example. Let's say that you want to see whether reading improves vocabulary in children of 6 years of age. And so your independent variable would be to assign one group of kids to read 2 books every night. And then the other group wouldn't have this reading assignment. Maybe they would just look at pictures instead of reading words. And then your dependent variable would then be you measuring their vocabulary at the end of a particular period, like at the end of 30 days. And that, again, would be your dependent variable. So in addition to having a dependent and an independent variable, your experimental design would also randomly select participants, so you don't have a bias in your sample. It would also assign them randomly to conditions, so you're not choosing maybe kids that are already smarter for one condition versus the other. And then you want to make sure that you are measuring all of the other variables that might influence children's vocabulary. So you might want to measure the children's school and make sure that maybe they're all coming from the same school. You want to probably make sure that all the children are getting a particular teacher and that the teacher reads the same amount of books. You want to control for the socioeconomic status of the parents, because we know that socioeconomic status is related to vocabulary in children. You want to make sure you control for age, so the children's birthday, and you want to control for IQ of the child. When you control for these things, it means that you are measuring this, because when it comes to doing your statistical analyses, you can see if any of these have an effect on your finding. And if they don't, then you can clearly say, we accounted for all of these variables. The only thing that showed an effect was that reading 2 books every day led to a vocabulary increase. And of course, you would have to make sure that you gathered a baseline. So before you run any of these kids studies, the study with these kids, you would measure their vocabulary at the very beginning. So with that being said, although experimental studies can lead to causal interpretations, not all experiments can provide causal explanations for all the questions you're trying to ask. And I'm going to dive deeper into this idea when we look at the different methods we can use to assess different questions. But this is basically how an experimental design has the power to infer causal relations between 2 variables. So another research design that researchers can use are case studies. Now, these aren't very common because case studies are usually reserved to explore people that have had really particular circumstances happen to them. So for example, there was this little girl named Jody that had seizures all the time. And in order for the seizures to stop, the medical doctors decided to remove a big chunk of her brain. And the question is, what's going to happen when you remove such a big part of a child's brain? Is she going to be incapacitated? Is she going to have developmental delays? Is she going to be able to function? And in fact, what they found is that because the brain is so plastic in early development, the other half of the brain that was still intact was able to compensate for her disability, which is incredible. She didn't really have any negative outcomes based on the fact that she got her brain removed. So again, you don't really see case studies very often because they tend to be a little more opportunistic. We also have cross-sectional designs in developmental or child development studies, and cross-sectional studies examine behavior in participants of different ages who are tested at the same point in time. And basically, researchers that have questions like, when or how do 4-year-olds versus 6-year-olds differ in their empathy display or their theory of mind? When you want to compare two groups of children, different ages, that's usually when you use a cross-sectional design. So some questions that researchers would want to explore with a cross-sectional design would be things like, how do millennials versus boomers view the pandemic? Or how much does empathy do 4-year-olds versus 6-year-olds display? Now, these children are not followed throughout time, so cross-sectional designs are not good for discovering how stable or different a particular characteristic within a child is throughout the lifespan or throughout a period of time, but it does help us compare different age groups. The next is a longitudinal design. And a lot of developmental researchers might say that this is the best design you can use for development because it really allows you to see how children change over time. So longitudinal studies examine behavior in the same participants over time. So it's not like cross-sectional studies because remember, cross-sectional studies study participants in the same time point. They're just different ages, where longitudinal studies study the same people, but over a period of time. So one question that you might explore with a longitudinal study is something like, how do cortisol levels, which is related to stress, of course, change in freshman students over the course of their first year. So you would follow the same freshman students for 1 year and see how cortisol changes. So we have gone over several designs that researchers can choose in order to probe the question that they're interested in or probe the hypothesis that they're wanting to test. So now we're going to move on to methods. And methods is really exciting because it shows you all of the different things that you can use in order to probe your question. So the methods that we're going to go over today are interviews, surveys, psychophysiology or involuntary responses, and voluntary responses. Of course, there's a lot more methods that you can employ, but these seem to be the most popular ones in child development. So an interview basically allows the researcher to test different abilities, responses, or ways of thinking of children by asking them questions. So one of the most famous interviews in child development is that of the Sally and Ann task, which we're going to dive into whenever we learn about theory of mind. But basically, in the Sally and Ann task, you tell children a story about how Sally had a little marble and Sally wanted to go play. So she decided to put her marble in the basket, and then she went and played. And then Ann took the marble and put it in her own box when Sally wasn't there. And then they asked kids, okay, Sally's going to come back and she wants to play with her marble. Where do you think that Sally's going to look for her marble? What they have found is usually 3-year-olds will say that Sally's going to look for her marble in her basket, even though that's not really reasonable because Sally wasn't there when Ann moved the marble. So Sally's not privy to this information, right? Only the kid is. But little kids, and we can discuss this task in more detail later, but little kids kind of have a difficulty in kind of comparing two perspectives, their own and someone else's, like Sally, the fact that Sally doesn't have the knowledge that Anne moved the marble. They kind of tend to have difficulty holding those at the same time, where 4 to 5-year-olds very easily say, oh, she's going to look in the basket and not the box because Sally wasn't there when Anne moved the marble in the box. So, and I think I might have mixed that up. 3 to 4-year-olds, the young ones, will say that Sally will look in the box because that's where the marble actually is, even though Sally never witnessed it. Where 4 to 5-year-olds will say it's actually in, or Sally will look in the basket because that's where she left it. And I'm going to provide a video for you of a similar task that shows this. It's not the Sally and Anne task, it's something else that you can look in that you can look below. So the other method that is common when studying child development is using surveys or questionnaires. So surveys and questionnaires are really useful whenever you want to measure things like temperament or language. And a lot of the times these surveys are given to parents to fill out, and sometimes these surveys or questionnaires are given to children. What's really important to note is that these surveys and questionnaires that we use in child development have been tested to make sure that they are valid, meaning that we are actually measuring what we want to measure. If we're giving a IQ test, we want to make sure that we're actually measuring IQ and not something else, and that they're reliable, meaning that if you were to give the same participant the same questionnaire, they would respond fairly consistently. So when you give kids or parents questionnaires or surveys to explore your research question, they always have to be valid and reliable, and these get tested over several studies. We also know that another methodology that you can employ is gathering physiological data, like brain activation during certain tasks, heart rate, skin conductance, and you can also gather involuntary measures like measuring where children look in particular pictures or scenarios. Now, what's really cool about doing EEG or MRI with children is that now you can ask questions like, what is the starting state of a baby's brain? Are different neural parts connected from the get-go? Are they communicating from the get-go? Are they specialized from the get-go? And you can do that by putting newborns in the scanner. Rebecca Sachs actually did a TED Talk on how it is that she's able to scan babies in order to answer these really cool questions, which you can look up. But now it's very common for researchers, well, maybe not very common because it's expensive and children move a lot, which is fatal to MRI studies, fMRI studies. But it is a possibility that they can use in order to probe how different brain regions are used or activated during particular tasks. EEG also measures electrical responses. And again, it allows us to see the type of regions that are active whenever children are completing particular tasks. Very relevant to infant studies in particular is measuring eye or gaze. So what's really, really fascinating about using eye tracking for infants is that it can tell us a lot about children's cognition or just how they see the world. So we know through several studies that children tend to look longer, infants, babies tend to look longer at things that they have never seen. They also tend to look longer at events that are unexpected. So if I were to show a baby that I let go of this phone and the phone floated or stayed in place instead of falling, the baby will look longer at the event of the phone floating versus the phone falling. And we also know that babies will look longer at things that are familiar or things that they prefer. Now, of course, there's little modifications to all of these looking time studies. But what's really cool is that, as you can see in this video, you can track exactly where children are looking and for how long. So the little dots on this video represent individual participants. And you can see that babies are really paying attention to the motion that's happening in a particular video. And then on top of that, you can also see how long children look at each different region. And if you show them a different video, you can also compare how long they look at one video versus the other. And that is how you can extract a lot of information from infants. Now we're going to go over different studies that use this methodology, but I just think it's fascinating that even though babies can't really talk to us, we can't really interview them, we can extract a lot from their gaze and where they look at. And then last but not least, you can do voluntary responses. So voluntary response is basically seeing how children react or respond to in different scenarios. What toy do they choose? Are they willing to cheat or not? Are they willing to help an adult or not? It is basically measuring their behavior, but in a controlled setting, okay? So usually voluntary responses are in the context of an experiment. So in my own research, I explore when children begin to be sensitive to how other people might evaluate them. And the way I do that is I offer children an opportunity to play with a remote that activates a little toy robot. And before they ever get to play with this remote, I kind of show them my opinion towards the robot moving, like I either like it or I don't. And then I allow them to play with the remote while I'm watching them, or whether I pretend to look away and read a magazine. And so the voluntary response I'm measuring is when children will choose to play with the remote. Are they going to play with it when I'm watching, when I'm not watching? How many times do they press the remote to activate the robot? So that would be a voluntary response. So as you will see in the video playing right now, I'm watching the child and the child doesn't really seem to be interested in playing with the remote. But then once I turn around, she begins to play with the remote and explore the robot. So this is an example of a voluntary response that you might measure in children, depending on your research question. So to summarize, studies in child development, of course, use the scientific method. We are always developing new hypotheses and testing them in a rigorous manner in order to get closer to the truth. Now, remember, we can never prove anything, but we are getting closer and closer to the truth with every new study and every hypothesis that is tested. We always develop hypotheses in order to provide evidence for the theories that exist, and only the theories that have a lot of evidence supporting them and hypotheses that have been tested and been supported stay in child development. And then, of course, when you have a hypothesis, you have a wide range of options to choose from, design and methodology that you can choose in order to test your hypothesis. So that is all I have for today. I hope that you enjoyed this video and that you have appropriate tools now to maybe design your own study or assess other people's studies.